Alright, this is the discussion we're going to have for skill builder number 4. We're dealing with 2D shapes, but now we're strengthening them. And in this activity, you went through and you rebuilt the square shapes that you had built before. And I'm going to draw one of these up here. And just to recap, as we applied different forces to it, the forces would come in, and depending on where the force was applied or what happened, you would get different things. So if we applied a force, say right here, and I'm going to redo that. I'm going to change our line here. And so if we apply a force right here, it comes in and it bends that beam. All right, it puts this beam under tension because we start to see a pushing out there. This will actually then squeeze these two beams in, and it's quite unstable. So we're going to pull that out. If we were to apply a force here on the edge, again we get an uneven bending of the force, and it doesn't hold up real well. So we've got to strengthen these squares. And then so you came in and you looked at ways of strengthening them. And that's the next part of this activity, is we're looking at how can we strengthen them. So I'm going to change my line. And you looked at different ways. There are a lot of different suggestions you could come up with. And something that was really easy to build and come up with and do would be to add a beam right across the middle, right there. And now you've got a cross and you're looking at it. You've done what's called triangulation. You've added a piece into it and you've made triangles now. We learned that triangles are very strong, they're very supportive, and they hold up well. And what we did to our square piece is we triangulated it. We caused it to have two triangles. So now if we come in and we want to apply a force to it, and we apply a load, let's say we want to come in at an angle, and I'm going to draw this in, and when we had applied a compression force, we had a force there. Hold on. We applied force there and there, and we compressed it. It would squeeze in, and what we had happen before was that the pieces would want to press out. Well, now that you have this bar connecting it, it holds it in place pretty well, and that doesn't let them move away. And if we get rid of those and we want to apply a compression force this way, well, again, this cross beam holds everything in place and doesn't let it move. So now we can see that adding this adds a lot more strength to it because the forces are moving along through this triangulation, and it's spreading out the forces across the entire structure and doesn't let it deform as easily. So, you should see that when you apply the force in any direction, any of the situations, any direction, anywhere you apply it, you could even pull on it. It's going to retain its shape, and it's going to be structurally stable. All right, this diagonal piece that we've added in has two different names to it, and we're going to look at both those names. We're looking at this piece right here, and when it's under compression, it's called a strut. Okay? It's called a strut when it's under compression. So when you're squeezing on it, when you've got forces that are applying on it inward, so your forces are coming in towards each other. When the forces come in that way, it's called a strut. Now, if it's under tension, which means that our forces are going outward, it's being pulled apart, then that piece is called a tie. All right? So remember those two terms, strut and a tie. A strut is when it's under compression, a tie is when it's under tension. Now, I want you to go ahead and replace you've replaced the base connects rod with a rubber band, and you see how these forces react and how they move along, and you've drawn these in. You've shown the arrows just as I did to show how these different arrows and how they affect each other. I'm going to erase this line, and that arrow is gone now. And so you're going to show these, whether it's in tension or maybe you've got a part that's in compression, and you're going to show those, and you can use the rubber bands to help you see that. So again, this is tension, and these lines, when they're this way, are showing compression because the arrows are going towards each other. The forces are moving in. As we saw in the last couple of exercises, we can see that triangulation makes things a lot stronger. So we're going to look at that a little bit closer. We're going to look at two different types of trusses. We're going to look at a queen post truss and a king post truss. So you've looked at these, you've done this. I'm going to draw them again, and we're going to show both of these trusses. So we're going to draw these in. I'm going to put some lines in there, and we'll make those black. And this is a queen post truss, and it comes up, and we want to undo that. I don't need the arrows in it. But a queen post truss comes in, has a square inside of it. It has 3 triangles. A king post truss, on the other hand, only has 2. And you saw the strengths and weaknesses of these 2 types of trusses, and you recorded some information about them. You also looked at a third design, and it came in and had pieces right here. This is a king post truss with a couple of extra pieces in it, and you saw that they keep getting stronger and stronger. Now, again, make sure that as you do these, you don't apply so much pressure that you destroy the rods. They will eventually break, but these structures are extremely strong. They're a whole lot stronger than what you've seen before, but the triangulation comes in and makes a lot of use of it. Now, it is important to note that your triangles have to be put in correctly. You want triangles to come into the middle of the beams, not out to the middle of the members and the beams, not out to the side. So if you came in and you made this and it went like this, yes, you triangulated it, but it's not nearly as strong as it could be, because now this beam is going to be moving laterally and wanting to push out. So as a force applies here, it's going to push this beam out. It's still going to break. Whereas a force coming in this way, coming laterally into this side, is going to push down, move down the center of this beam to the middle of this bottom beam here. And that's what you want to try to do, and that's what you're going for. In the next part, you went in, you built the square again. But this time, instead of coming in and putting a rod in between, you put a string in there, and I'm going to show that string. We're going to draw a thin little line in there. We're going to make it red, and then here's our string. Now, you've seen this with wires and cables and other things that come in to support structures. Now, how can this string actually make this stronger? Because if we were to come in and apply a force to it, and we're going to put this force, we're going to put it in blue. And we're going to push right here. We're going to compress right there, and that is just too small. It's too small of a force. Let's get a bigger force than that. And we come in and we apply force right there, and we come in there. And as we apply that force, the first thing that you see happen is these 2 pieces will collapse in, because the string's not going to apply any pressure to that compression. So it's now the string, if we did it the other way, and we came the other direction with it, and we applied a tension force, or a tensile force, you'd see that string would hold up, it would pull against it. So strings and ropes are good in tension, but they're not good in compression, this direction. But what happens, so the string itself has to be in tension, so the direction on these 2 corners has to be in tension, whereas if you're applying a force here, you want that force to be in compression, because the compressive force going this way is going to make these 2 corners want to push out and put the string under tension again. So that's what you want to look at in this next part as we go through looking at how do the strings make it stronger. Now, one way we could make this string a lot stronger by using the string is, instead of just putting 1 string, we went in and put 2 strings. So we're going to add a second string. Let's get our little thin line here without the arrow. We're going to add a second string across this way from this corner. Now we can get both strings being in tension, because again, the strings, ropes, those all have high tensile strength and can hold up really well. So we apply a force at any corner, we're always going to have one of these 2 strings under tension, and then it's going to hold everything in place and keep our structure sound. And that's what we're looking for, is a way to keep the structure sound without adding a lot of weight and expense. And you'll see this in buildings and other structures where they'll use what's called guy wires across to hold things in place. You can also do this if you put a plate or something over it as well. And you went through an experiment and you did that on it as well. We went through on the same piece, and we're going to get a new one here. And I'm going to draw a new piece. You went in and you put, we had this, and we come in and we draw our square. and then you went in and put a piece over it, and it was quite large. Came across it this way, and that's the wrong size. We want that. And it came across this way. Instead of being, it was a beam, and you applied it to it, and now you can move it. It's got high tensile strength and high compression strength. All right. Something else that people will do sometimes is they'll come in and they'll actually put a plate over the entire surface of it. So we're going to show this plate in here, and we've got, I'm going to draw this in. So they'll come in and they'll put that in there, and then they'll come in and put a second plate, and they'll fill it in, and we're going to fill this second plate in with green. And as we put this plate over it, we'll see that it covers it up and covers the whole thing quite nicely and allows everything to be covered up. And again, we get our holding patterns. We get the strong in compression and tension because it's holding it in all the different directions. And you try that out with your cards.